Hello, my name is Puteri.
And hi, my name is Irdyna binti ZAINOL, and in this video, we're gonna talk about the pilot wave of de Broglie. So, let's see it. But first, let's get to know who is de Broglie. His name is Prince Louis Victor Pierre Raymond de Broglie. He was born on 15 August 1892 in France and died on 19 March 1987, also in France. He is a French physicist. In 1922, he postulated in his doctoral dissertation that because photons have wave and particle characteristics, perhaps all forms of matter have wave as well as particle characteristics. Let's see about de Broglie wavelength and take a look at de Broglie ideas in more detail. He concluded that the wavelength and frequency of a matter wave associated with any moving object were given by lambda equal to h over p, which the formula is the de Broglie wavelength, and frequency equal to E over h, where h is the Planck's constant and p is the relativistic momentum and E is the relativistic energy of the object. The value of Planck's constant given is equal to 6.626 times 10 power of negative 34 meter square kilogram per second.
Hello, I'll be explaining about the de Broglie explanation of quantization in Bohr theory. Before we go to the further explanation, what is Bohr theory? So in Bohr theory, we must understand that the electron orbit the nucleus and the radius orbit correlates to the electron energy. The larger the radius, the higher the electron energy. And as the electron transition move from higher to lower energy, there will be the differences energy as it will emit the specific color of light. The larger the transition, the higher the photon energy. Then, the photon energy can be calculated by using the formula, which is the photon energy is equal to the electron change of the energy. That is a fast explanation regarding to Bohr theory model of atom. The Bohr model of atom has raised a problem where it cannot explain how electron can evolve around the nucleus. The theory has come up with a question on how to understand that only certain electronic energy are allowed and why atoms of given element have precisely same physical properties regardless the infinite variety of starting velocities and position of electrons in each atom. So de Broglie has came up with a theory to explain of the quantization of Bohr model. He said that the electron is traveling freely around the nucleus. He argued that the electron in its circular orbit must be seen as a particle wave, as it is traveling as a wave, and the electron can only exist as a standby wave at specific discrete energy. The example that we can use for his statement is when we plug a guitar string. When we play the guitar, the particle wave can lead to standing wave under resonance condition as a vast number of wavelengths are excited. The wavelength that consists notes at the end will form the standing wave in the string. In the string, the standing wave are formed when the total distance traveled by a wave down the string and back in one wavelength or any integral number of wavelengths. The wave with different wavelengths will interfere with each other and the amplitude will become zero. Another aspect of the Bohr theory that is also easier to visualize physically by using de Broglie's hypothesis is quantization of angular momentum. that allow both orbits arise because of the electron-matter wave interfere constructively when an integral number of wavelength exactly fits into the circumference of a circular orbit. Thus, we can calculate that n lambda is equal to 2 pi r, and as lambda is equal to rate of h over product of mass and velocity, the angular momentum will be the product of n and h.